Before I get started with this mini lecture on part of Chapter 9, I want to point out something. Although there can be many observed differences between cultures, we tend to focus too much on such differences. Differences are interesting, but we can go too far with that focus because in general, all human beings are more like each other than they are different from one another, at least in terms of the broad strokes, in terms of overall emotional reactions, personality types, behaviors, and just human traits. Human beings develop along common trajectories, regardless of their culture or country. We tend to think that our cultures are dramatically different from one another, but we're usually basing that determination on superficial things, like clothing that's worn or languages spoken. In reality, there are even more individual differences between us within our own culture than there are differences between cultures, like between the US and China. Just food for thought. When we think about something, we're using mental representations. When you think about a chair, obviously you don't have a literal chair in your brain. You've got an image of a chair, or maybe you have a concept of how it feels to sit in a chair. These mental representations can involve more than just visual images, although we do interpret our worlds to a large degree through our sight. A concept is a categorization we come up with. We organize what we encounter in our world and group similar things together. You know that a lazy boy recliner and a hard wooden chair, although different from one another, are still both chairs, fitting in that same one category. But you probably have a specific prototype for chair that looks more like one of those than the other. Since we don't use hard wooden chairs much anymore, that's probably not what you think of when you hear the word chair. When you hear car, if you drive a truck and your family always had trucks, you might not envision a VW Bug when you hear that word. And most of us don't think of flip phones or corded phones now that cell phones are around. In Texas, if you hear Coke, you might actually think immediately of a Dr. Pepper. Here are some issues that can occur when we problem solve. Sometimes we can't get past the typical function of something. Can a pen only be used for writing? We could also use it as a weapon or to hold our hair behind our ears, but often we can't get past the more typical function. There's actually interesting research that suggests simply washing our hands can help us overcome this tendency, our functional fixedness, and help us reset our minds so that we're open to new ideas. Hand washing figuratively and psychologically separates us from what came before, and literally from the dirt we acquired. So maybe before you take part in a brainstorming session, go wash your hands. What's a mental set? When you use the term mental set, set is a key part of the phrase. You've always done it this way, it's worked before, so you'll keep solving your problems the same old way. It's set and firmly established. Having an entrenched mental set sort of kills any chance of using creativity to solve problems. What's a confirmation bias? When we come up with an idea about why some problem has occurred and then start operating with that specific idea in mind, it's very often hard for us to give up on that approach. Instead, we tend to look for information that will show us that we did the right thing after all, that we had the right idea from the very beginning. This is a huge problem in scientific research because sometimes without realizing it, investigators will only see and use the data that supports their hypothesis and ignore anything that doesn't fit. In fact, they'll look for what they expect and want to see. They have a bias toward confirming their ideas. We see this in the polarization of political ideologies as well. People desperately, even childishly, want to hang on to their long-held beliefs because of confirmation bias. Experts are often more prone to polarization and to clinging desperately to their beliefs. They've learned to rely on themselves and use technology and science to prove themselves right. This might also be due to the fact that human beings suffer from overconfidence, believing that we are correct more often than we are, and thinking that we are so accomplished that we'll quickly finish tasks, when in fact it takes on average 2 times as long to complete things as we initially predicted. A common problem for students expecting not to need quite as much time to read that chapter or finish a paper. Sometimes, because of overconfidence, people who actually don't know all that much, in fact, sound like unwavering, firmly decisive experts who can more easily sway the opinions of others. We need to be able to think creatively in order to solve problems, so that we can think of new ways of approaching those problems. When we engage in divergent thinking, we're brainstorming, which is a creative process and will allow us to come up with several different possible solutions. I don't know if y'all read or watched the movies for the Divergent series, but the premise of that series was that certain people were different than expected. They didn't conform. They diverged. The word divergent means to be different, to go off in a different direction, taking a new path. Convergent thinking takes place when we need to come up with the one correct answer. It utilizes logic and taps into our knowledge base. Just like cars might converge at a single on-ramp to the highway, all narrowing together into one spot, so too does your thinking converge in one direction to come up with a single answer. Interestingly, if we dance a structured dance or one with set steps, that type of movement aids our convergent thinking, making our thinking faster. If we freestyle dance with no required steps, that boosts our divergent thinking. Sternberg identified 5 components of creativity: expertise, imaginative thinking skills, having a venturesome personality, possessing intrinsic motivation, and being immersed in a creative environment. First, the more experience we have with something, the better we can think outside the box and be creative with the individual components. Knowledge and familiarity equip us with the basic understanding we need to go off in interesting new directions. Someone who has imaginative thinking skills is able to see things in new ways, to see patterns and connections between things, and to be able to piece things together from multiple possible solutions to create the best solution. People with venturesome personalities are more open to new experiences and new approaches to problems. They're able to handle ambiguous or uncertain situations, even risky situations, and they exhibit perseverance, not giving up until they have solved the problem. Immersing someone in a creative environment and surrounding them with other creative people helps by virtue of the fact that very often more brains are better than one, particularly when brainstorming possible solutions, and also because feeling supported and encouraged wakes up the creative juices. Sometimes creative environments are noteworthy because they provide protected time for people to simply be creative and not worry quite as much about the daily grind type of duties. While it's certainly true that having more people brainstorming sometimes results in more ideas, individuals triggering new ideas in the others, sometimes the opposite is also true. Research has shown that sometimes actually going into social isolation and not brainstorming with multiple brains can be the most helpful to an individual person's creativity. Simply being away from the social responsibilities of conversing with others, politely hearing and considering their ideas, and dealing with the distraction of being around others can free up your mind. Going off by yourself can sometimes allow you to focus in on your thoughts and ideas and can actually boost your personal creative thinking. I know some authors, and they talk about this a lot, that they need to be alone to think and write. Behaviorists like Watson and Skinner believed that all learning, including language development, takes place because of our interaction with stimuli and the resulting responses or consequences. They believed that children learn to associate letters with sounds and combinations of letters with words, and when parents reinforce them for correctly pronouncing a word, that leads to the child learning how to say it. But some researchers thought that the behaviorists were being too simplistic when it comes to learning language, because very often children utter complete sentences they've likely never heard before and weren't reinforced for. They're able to apply syntax rules and create their own original sentences, like we see with over-regularization, which is when they overextend the grammar rules they've learned, such as when they say things like "I goed" instead of "I went." Noam Chomsky was a linguist, and he promoted the nativist position, believing that all human beings are born with the innate ability to learn language. He thought that we are all born with a specialized language acquisition device in our brains, which allows us to learn grammar and vocabulary. It's not a literal spot in our brains like the word device suggests. It's just the innate skill for language that we're all born with. Chomsky also talked about universal grammar. All languages share certain similarities, like having nouns, verbs, and adjectives. Researchers following the interactionist perspective believed that it's a combination of our genes and environments that lead to language acquisition. It's through our social interactions that we learn and develop our language skills. Where we live determines the languages we'll hear and thus learn. It's also in our genetic code to be social beings, to communicate with one another, and so we learn our language because we're driven to communicate our needs and ideas to those around us. Whether there are lots of different types of intelligence or just one overall number for how smart we are, researchers have wanted some way to objectively, scientifically measure intelligence. The first widely usable intelligence test was created by Alfred Binet in France when the French school officials asked him to come up with a way to figure out which children needed to be placed in special education classes. Since Binet developed his test for French children, a professor at Stanford, Louis Terman, adapted the test to use with American children. Terman also further developed it and set new guidelines for different ages. That resulted in the test that is still used today, the Stanford Binet. Binet developed a measurement known as mental age, which was the age at which most average children could perform tasks. If most 10-year-olds can do task X, and the 10-year-old you test can also do task X, then that child has a mental age of 10. He can do what his same-aged peers can do. Of course, chronological age is our actual age in years. Another researcher, William Stern, devised the intelligence quotient, commonly called IQ, to come up with a score for each child tested. That figure was the child's mental age, based on the test results, divided by their chronological age, and then multiplied by 100 just to get rid of the decimal and make the number easier to use. Today, we don't normally use IQ scores. The language, actually saying the phrase IQ score, is often still used, but rather than coming up with that score according to that formula, we instead acquire a large pool of normative data and then compare the test taker score with the average score. Normal bell curve is a term you'll hear a lot if you continue to take psychology classes. Almost everything we study can be plotted onto a normal curve, like this. You see here that most of the scores are in the middle, and then you'll always have some people scoring on either of the two extremes, referred to as outliers. On this graphic, we can also see how much the scores of those tested deviated from one another, or how much they differed. This tells us what the range of scores was. Coming up with the ranges of score differences, how much the scores vary from the mean, is called standard deviation. It's basically the average score on a particular test compared to your score. How much did your score deviate from the average? And what was the overall range of difference in test taker scores? With IQ tests, we've determined the standard deviations that happen among all of the human beings who take it. A 100 IQ score is considered average. 95% of all intelligence test takers score between a 70 and a 130. 68%, more than half, score between 85 and 115. While Binet and Terman revolutionized the way we thought about and tested intelligence, today other tests are more commonly used, such as those developed by David Wechsler. That CH is pronounced like an X. Wechsler developed different tests for adults and for children. The WAIS test is for adults, and the WISC for children is used in schools here in town today. These evaluate the person's processing speed, working memory, and reasoning skills. People are asked to do a number of activities, assessing their understanding of similarities, vocabulary, letter-number sequencing, and block design, actually using blocks to assess their understanding of shapes, sizes, and spatial reasoning. What do all of these terms mean? It's through norms or normative data that we're able to compare people. When you administer a test, you get a bell curve and can see how everybody did and what's, quote, normal for the people who took it. If you give this same test to lots of people, you come up with even better data about what average people score, and that lets you compare people. Anybody can make up a test, but not all tests are good ones. There's a rigorous process that psychological tests go through before they're used. When a test is standardized, it goes through something like a test run. The test is given to a group of people who are much like the target population. So if I designed a survey that I wanted to use with college students, I wouldn't go to the nursing home to administer it. In the standardization process, investigators will make sure that the test questions make sense to the respondents. From there, they can compare the test group's scores with their target group's scores. So standardization results in the ability to compare the test taker's score with those of a representative sample. That ability to compare people's results makes it a meaningful test. If you can't compare data, the results from that test won't tell you very much. Another measure they evaluate during the standardization process is the reliability of a test. Essentially, reliability refers to how consistent the test is. If I take a test today, presumably I should still get the same score tomorrow, or at least close. And if you're talking about a personality test, Even if I take it a year from now, I should probably score about the same, since most theorists believe that personalities remain relatively stable over time. Reliable tests result in consistent scores over and over and aren't dependent on who administers the test or where you take it. Very often there will be scripts that test administrators must follow to increase the overall reliability. Validity is evaluating whether or not a test is actually measuring what it's supposed to be measuring. You know those BuzzFeed personality quizzes you can do on Facebook? Just because I pick the red color blob, that doesn't mean that I'm a dominant, aggressive person. Those tests are not valid. Content validity refers to how well the test measures what it's trying to measure, its content. Predictive validity is slightly different. It measures how well the test can predict future behavior. In Scotland, all 11-year-olds were administered an intelligence test in 1932. The researcher Deary found survivors who were still alive at 80. He gave them the very same test they'd taken at 11 and retested them again when they were 90. Results were striking. Intelligence was incredibly stable over those many decades. He also found that those with higher intelligence lived longer, probably because they also lived healthier lives. With regard to the different theories about intelligence, some theorists simply believe that if your brain works fast, if you're able to quickly understand a situation, call upon your memories, weigh your options, and begin solving problems, then you're smarter. How fast you are, your processing speed, called fluid intelligence, is what determines your intelligence. Whether you buy into this view of intelligence or not, we do know that our speed and overall intelligence are at least very highly correlated. High fluid intelligence allows us to more easily learn new things. Both fluid and also crystallized intelligence are impacted by the passage of time. Younger people have higher fluid intelligence than aging adults. But older adults have higher crystallized intelligence, which is a lot like wisdom. It's the intelligence you build up over time with experience.